So we're asked to solve the problem. The logistic growth function f of t equals 440 over 1 plus 4.5e raised to the negative 0.14t. And that describes the population of a species of butterflies t months after they are introduced to a non-threatening habitat. How many butterflies are expected in the habitat after 11 months? So keep in mind in this problem, they're telling you that t months. So the t in the problem represents the number of months. So here they're asking us after 11 months. So we know again that t would equal 11. So all we need to do to solve this problem is substitute 11 in for t in the original function. So now we would have f of 11 equals 440 over 1 plus 4.5 e raised to the negative 0.14. Now in place of t, we're going to put in 11. So now in your calculator, you're going to enter the 440 over 1 plus 4.5 e raised to the negative 0.14 times 11. And that gives you 223.951. So the next problem, again, we're solving. It says the value of a particular investment follows a pattern of exponential growth. In the year 2020, you invested money in a money market account. The value of your investment T years after 2020 is given by the exponential growth model. A equals 6,300 times E raised to the 0.054t. It says, how much did you initially invest? So initially investing means how much did you invest in the year 2020? So remember, t years after 2020. So in this case, since it's 0 years after the year 2020, we're going to substitute 0 in for t. So we'd have A equals 6,300 E raised to the 0.054 times t, and t in this case is 0. You don't really need a calculator for this one. So we know that this would be 6,300 E raised to the, anytime you multiply anything times 0, it gives you 0. And remember, anything raised to the 0 power is 1. So this would be 6,300 times e to the 0, which is 1, which gives us our initial investment of $6,300. Our next problem is a multi-step problem. So here we have a fossilized leaf contains 40% of its normal amount of carbon-14. How old is the fossil to the nearest year? Use 5,600 years as the half-life of carbon. So half-life, what does that mean? That means how long does it take something to break down to half of its size? So let's say half of its mass. So let's say we have something that's 40 pounds. Half-life means how long will it take till it becomes 20 pounds. Then half-life of a 20, of course, would be 10, etc. So half-life, how long does it take for something to break down to be half of its mass? So in this problem, we're going to use the exponential growth function, a equals a sub 0 times e raised to the kt. Now, a sub 0 represents the initial amount. E, of course, is our natural base E. K would be the rate of change, and T would be the number of years. So in this problem, we first have to find K because we're given the number of years. So you say, well, what about A and A sub 0? So remember, since we're talking about half-life, A sub 0 would represent the initial amount. It doesn't make a difference what you choose. So let's say I used 2. So A represents the amount left after a certain amount of time. So if I start out with 2 and I'm talking about half-life, then I'm interested when it will become half of 2 or 1. So again, it doesn't make a difference what you use for A sub 0, but A will always be half of that. And so this is times E. We're looking for the K. And T, remember, is years. So in this case, it tells us the half-life is 5,600 years. So I'm going to start by dividing both sides by 2. I'm just going to switch the order. It doesn't make a difference. So this would give me 1/2 equals E raised to the 5,600K. Now remember, I'm solving for K. So what I'm going to do, since I'm dealing with base E, is apply the natural log of both sides. So when I do that on the left-hand side, I have the natural log of 1/2, and I'm going to change that to a decimal, 0.5. It'll be easier to put into my calculator. And remember, the natural log of base E raised to any power is the power itself. And then I would wait to put it into my calculator. So what I'm going to do is, since I'm solving for K initially, I'm going to divide both sides by the 5,600. Now on my calculator, I'm going to go ahead and enter the natural log of 0.5 over 5,600. Now on your calculator, it's going to give you something like this, negative 1.23776282. Then it's going to give you e to the negative 4th. Okay, this is similar to what we talk about in scientific notation. So this really means if I want to change this to its proper decimal form, I need to move it 4 places to the left. And again, that's what K would equal. But the good thing about our calculator is it will store that value. So don't touch any other buttons on your calculator, and let's do the second part where it says a fossilized leaf contains 40% of its normal amount of carbon-14. So now we're going to go back to our growth model. And we're going to enter the information. Now, when we talked about half-life, the A was half of the A sub 0. When we're talking about 40%, it's the same type thing, that A is 40% of A sub 0. So the easiest way to do this problem is to put in 40 equals 100 because 40% of 100 is 40. And that's times E raised to, and I'm just going to write the answer. I'm going to show you why in a minute, times T. So I'm going to divide both sides by 100. So it's 40 divided by 100, which is 0.4. And that's going to equal E, and again, raised to that answer I got earlier, and I'm just going to leave it as that, times T. Now again, since I'm dealing with base E, I'm going to take the natural log of both sides. And that gives me the natural log of 0.4 equals that answer times T. And I'm going to put that in parentheses. Now, in order to solve for T, I'm going to divide both sides by the answer. And the reason I'm doing it the way I'm doing it, so it'll be easier for you to enter it into your calculator. So now on your calculator, all you're going to do is put in the natural log of 0.4 and divided by, or in your denominator, you're going to put in answer. Now, how do you do that? You're going to hit your second key, which is the blue key, and then the negative key, which is on the bottom inside parentheses. And what that's going to do is take that stored answer that we found before, that negative 1.2377, etc., and divide the natural log of 0.4 by that. Now you'll hit enter, and that will give us our answer of 7,402.79. Now it says round to the nearest year. So the nearest year, since this is a 7, would round our 2 up. So the answer would be 7,403. Okay, so we are going to have to find that K first. And we're going to go through a similar problem with the next example. So here it's telling us to solve the half-life of silicon 32 is 710 years. If 100 grams is present now, how much will be present in 1,000 years? So again, we need to find that K first. So it says the half-life. So remember what we did before. We put a 1 in for A, and we put in a 2 in for A sub 0. And that's raised to the E, and then K times T. Well, this is telling us T is 710. And again, we're going to be solving for K. So just as we did before, we're going to divide both sides by 2. Okay, so again, I'm going to change 1/2 to 0.5 because it's easier to put in my calculator. Next, I'm going to take the natural log of both sides since I'm dealing with base E. So this gives me the natural log of 0.5 equals 710K. Next, I'm going to divide both sides by 710. Now you're going to put this into your calculator in order to find what K equals. So we're going to take the natural log of 0.5 over 710. And that's going to give me negative 9.762, etc. And again, it's going to give us that e to the negative fourth at the end. So remember, we're just going to hold that in our memory in the calculator. And now we're going to come back to our growth function. And put in the information given. Okay, so it says if 100 grams is present now, so remember now is that a sub 0. So that's where we put in the 100. We have our base E. We know what our K is, and we know what our T is. In this case, it says 1,000 years. So T is 1,000. And again, I'm going to use A and S to refer to that number I'd be plugging in for K. Now what I'm going to do, since I'm solving for A, I'm actually going to put the information into my calculator. So I'm going to do 100. Then I'm going to do that times E raised to the 1,000. Then times my answer. So that's where I'm going to hit my second key and that negative sign within parentheses and hit enter. So A would equal 37.671. It says round to 3 places. So since 6 is to the right of my third place, that means I'm going to round up. So my answer would be 37.672. Now what I've done is I've written down the steps to put that last problem into your calculator. So that you'll be able to do that and see the steps necessary in order to get that answer.